Hello friends and welcome. Let's look at this challenging question on Math Olympiad. This is from calculus, the aspect or branch of mathematics we call calculus, and this one is in particular integration. And in this question, we are asked to evaluate this. So is this something you can do? Let's know what your thought is in the comment section, and you can join me. Let me expose you to what to do, and it's very simple. To answer this, I want to remind you of, generally, if you have the integral of x to the power of n with respect to x, dx, to integrate it, it is x to the power of n plus 1, use this power to divide, then plus a constant c. But note that this formula is used if the function given is in this form where there is no denominator. If you look at this, you notice this is a rational function. And because it's rational, we cannot easily apply this formula. So, but before then, let me show you what you will do before you apply the formula. Join me. Now, what you will do is, to answer this kind of question, we make use of what we call substitution technique. Okay, so we're going to integrate by substitution technique. So in that case, we can now say we start with solution, and this will give us, we now say the denominator, the radicand, which is the value in the radical sign, we can say let it be u. So u is equal to 1 plus x. Now what do you do with this u? Remember, you can also say that u, subtract 1 from both sides is positive. So if you subtract 1, we have this is equal to, if you subtract 1 here, it becomes 0, is equal to x. So it means that u minus 1 is equal to x, or you can say that x is equal to u minus 1, whichever. Now, what do you do with this? Let's go back to this function. So this is going to give us integral from 0 to 3 x squared. Remember, we've said x is u minus 1. So we're going to replace this x squared with u minus 1 and raise it to the power of 2. Then plus, this is 2. Our x is also u minus 1. All over, this will give us square root of, we have said that the whole of this is our u. So we have u and we have the x. Now, at this point, what do you do again? Let's simplify what we have here. So we have u minus 1 raised to power 2, means this will be twice. So in that case, it is u minus 1 and u minus 1. Okay, so use this to multiply. You have u squared. Use this here, we have negative u. Use it here, you have negative u, and this will give us positive 1. And in that case, you have u squared. Add this, remember their coefficients are negative 1. So it will give you negative 2u plus 1. So for expanding this, we have this. So we're going to have integral from 0 to 3. This has given us u squared minus 2u plus 1, plus, use this 2 to expand this. 2 multiplies will give us 2u. 2 multiplies will give us negative 2. And this is all over square root of u dx. Now, at this point, you will notice that this is now a function of u. And in that case, there will be need for us to remove this dx. Because if you look at the question, it was given as a function of x. That was why we said integrate with respect to x, which is this. Okay? But since this has become a function of u, this should be removed to become function du. So how do we make this to be du? Let me show you what you do. So in that case, we are going to say, this is going to give us, to get this, to replace this, remember we have already said that u is 1 plus, that u is equal to 1 plus x. Now what we do is, if we differentiate this u, we are differentiating it with respect to x. So in that case, we are going to have du dx is equal to, remember your rule of differentiation, if you have y is equal to x to the power of n, to differentiate it, we say is dy dx, because the function of y and x, what do? Use the power to multiply and then take 1 from the power. This is for your differentiation. So in that case, if you differentiate 1, if you want to know more about differentiation, check the link in the comment. Each time you differentiate a constant, which one is one of them, it gives you 0. Then this x has a power of 1. So using this formula, use 1 to multiply. You have 1x, take 1 from here, you have 1 minus 1 is 0, and x raised to power 0 from your indices is 1. So this is the same as what? Saying 1 times 1. And 1 times 1 is the same as 1. So what does it mean? To differentiate x is what? 1. Okay, now that you've gotten this, it means that du dx is equal to 1. Make this to be in fraction, you cross multiply. So we're going to have du times 1 is du, and the x times 1 is the x. So we say that du is equal to the x. So you see, we can easily replace this dx with what? Du. Have you seen that? So in that case, from here now, we're going to have integral from 0 to 3 of this. So we have u squared. Let's simplify. This is u squared, negative 2 plus 2u. This will be off, is 0. Then 1 minus 2 will give us negative 1. Okay? All over square root of u. Then this we are going to replace with what? Du. See, we've gotten something now. Now, at this point, you will now see that the value we have at the denominator is just a term, but this was it is given as an expression. So for this one, there is a term. We can still break it down so that we use this to divide each of these terms at the numerator. So we're going to have integral from 0 to 3 of u to the power of 2, divide it with this, minus 1 over this, then du. So what do we do next? It's becoming interesting. So we're going to now say at that point that this, remember your rule of indices, that each time you have square root of a is the same as a to the power of half. Okay? And another rule says if I have a raised to power n divided by a raised to power n is a raised to power n minus n. You subtract the powers. So let's apply this here. This will give us integral from 0 to 3. This is u squared, and it's been divided by u raised to power half. Did you see that? Minus 1 over. This will give us u raised to power half, then du. I hope this is cleared. So what do you do again? You are now going to return this, which will give us integral from 0 to 3, u squared. Because we are dividing, you are going to subtract the powers. Okay? Minus. Also note that in your indices, if you have 1 over x is the same as x to the power of negative 1. I hope it's cleared. So in this case, this will now be u to the power of negative 1 over this power, then du. So you see, we have now been able to reduce this rational function to a function that is in this form. And at this point, we can apply this method. So if we simplify to have 2 minus half will give us u raised to power 3 over 2. If you subtract this, you have 3 over 2 minus this will give us negative half du. So let's now apply this rule we have there. So if you apply it here, it's going to give us now. This will give us, so when you start integrating, you remove the integral sign. So in that case, we are going to have u raised to power 3 over 2. Remember, you are adding power of, you're adding 1. Then use the power to divide. Okay? Minus, this will give us u raised to power negative half plus 1. Use the power to divide. And in this case, we are not putting the constant c because this is a defined integral. So when you have a defined integral where there are values here, we don't usually put the constant. So we can now have from the value given from 0 to 3. And you know that these values are values of x. And this one is also value of x. So what you do next is, at this point, we are going to simplify. So if you simplify, you have, this will give us, add this, you are going to have 5 over 2. If you add this, will give you 5 over 2 minus u, add this, it will give you half, Add this, it will give you half, ranging from 0 to 3. Because we are dividing, these two we have to go up. So we're going to have 2u raised to power 5 over 2 all over this 5 minus these two will go up. So we have 2u to the power of half all over 1, which is the same as that. Then we have the value of x from 0 to what? To 3. So what do? You can choose to work with x value or you can replace it with u value. Now let's go with replacing with u value, okay? So in that case, remember we said earlier that our u is equal to 1 plus x. Did you see that? So when x is 3, what do you think should be the u? Our u will be what? 1 plus 3 to give us 4. So when x is 3, our u is 4. And when x is this 0, what do? Your u will be 1 plus 0, which will give us 1. So in that case, we are going to have it from there as 2u 5 over 2 all over 5 minus 2u to the power of half, ranging from, we are now having u as 0 now and u as 4, no longer 0 and 3. But you can still choose these two to work with. In that case, if you want to work with this, you have to replace the value of u here with x. I hope you got that using this. So you're going to replace what you have here with 1 plus x and then choose to use this. I hope this is clear. So let's go with this now. We're going to now have 2, our u, for this, you take from the highest minus the lowest. So we're going to have 2, our u is 4, raised to power 5 over 2 over 5 minus 2, our u is also 4 to the power of half. And whatever thing I have minus, let's reduce this, minus, put in the value of 1 in this also. So it's giving us 2 into 1 raised to power 5 over 2 minus 2 into 1 raised to power half all over. Okay, this will be all over 5. Okay, so let's simplify. If you simplify this, it gives you, this will give you, square root this, it will give you 2. And we have 2 times 2 raised to power 5 minus 2. This will give us 2 if you simplify it, okay? Minus this will give us 1 to the power of anything is 1. So 1 times 2 is 2 over 5 minus this will give us 2 over 1. So let's simplify. If you simplify finally, we are concluding. If you simplify finally, you are going to get your value as, multiply this with to give you 64 over 5 minus 4 minus, simplify this it will give you, this will give us 10 minus 2. Okay, what we have here is, okay, so we have 2, it will give us 2 minus 10 all over 5. So in that case, simplify again, we have 64 minus 20 over 5. Use this to multiply, gives you 20 over the denominator. Minus, this will give us negative 8 over 5. So when you now simplify further, it's going to give us, remember you can still use calculator at this point. So it's going to give us, subtract this, you have 44. If you open this, you have positive 8 and the denominator is the same. So add this up, it will give you 52 all over 5. And this becomes your answer for integrating this particular question. And I hope this really helps and answered a lot for you. Let's know how much in the comment section. Remember, you can ask questions. We'll get to that and respond. Please help us to share this with your friends and colleagues. Give this tutorial a thumbs up and subscribe for the more you'll get. I'll see you in our next class. Bye-bye.